Hello student, we are providing Centennial online classes as we are working from home. Today I will discuss class 12th chemistry chapter 8 and today topic is general trends in chemistry of D block elements. In previous video already I have discussed the general properties of transition elements and D block elements, and today I am going to discuss here the general trends in chemistry of D block elements. And now I will start here the atomic radii. Atomic radii, this is the general properties of periodic table, and as you know the atomic radii across the period decreases and down the group increases. But in case of transition elements, the atomic radii across the period across the series first decreases up to the middle elements, then remain constant, and after that increases slightly. So now you see here, if we place the elements in graph, then you will study here. In this axis we have taken the atomic radii and this one is the atomic number. So according to this properties, atomic radii up to middle elements decreases, then remain constant, and after that slightly increases. So now you see, atomic radii up to middle elements means up to Mn decreases. Why it is decreases? Because effective nuclear charge increases as atomic number increases, number of proton increases, and as a result effective nuclear charge increases. That is why atomic radii decreases. This is the general properties. But after middle elements further it increases. Why? Question is here, why it is increases after the middle elements? Because atomic size should be decreases up to last elements, but here after middle elements further increases. Why? So in this case, now you see, as atomic number increases, electrons enter in d orbital, and d orbital, that is the penultimate cell here. Penultimate cell means this is the n-1 d and 4s ns here. As the atomic number increases, electrons will start to enter in d orbital, and after the middle elements the screening effect increases, because number of electrons in d orbital also increases, which causes the shielding of outer ns orbital. That is why ns orbital get less effective nuclear charge and atomic radii further increases. Second point is here, atomic radius gradually increases down the group, but difference in atomic radius between the second and third series in very less due to poor shielding effect of 4f. Now you see, this is the second point. Second point is here, when we observe the graph in this case, so in second series atomic radii further decreases up to middle elements, then further increases, and in case of third series elements this also follows the same trends here, but second series and third series atomic radii almost similar. Question is here, why? Why both second series and third series elements having the same atomic radii? Because in third series, as atomic number increases, electrons enter in 4f before 4f before 5d, and 4f causes poor shielding. As a result, greater effective nuclear charge is applied on outermost orbital. As a result, atomic radii gradually decreases. That phenomena is called the lengthened contraction. So due to lengthened contraction, second series, this is the second series and this one is the third series, elements having almost similar atomic radii. Again I will explain here. Question is here, second series and third series atomic radii is similar. Why? Their atomic radii difference should be large, because in second series and third series having different number of orbital, that is why their atomic radii cannot be similar. But in this case both second series and third series elements having the similar atomic radii. Why? So in third series, as atomic number increases, electrons enter in 4f before 5d, and 4f causes poor shielding. As a result, greater effective nuclear charge is applied on ns2 orbital. Therefore, atomic radii gradually decreases, and this phenomena is called length and wide contraction. So due to length and wide contraction, third series and second series elements having the similar atomic radii. And next properties is melting and boiling point of the transition metal. Now you see, second general trends here, melting and boiling point. So under the melting and boiling point, the transition metal have very high melting and boiling point. Everyone know this thing, transition metal having the high melting and boiling point, because they having the strong metallic bond, because they have incomplete d orbital. Therefore delocalization of electrons take place and form the stronger metallic bond. That is why they have the high melting and boiling point. But some variation is here, so I will clear here. The melting point of these metals reach as a maximum value and then decreases with increase in atomic number. So now you see, in this graph, now you draw the graph here. So this is the melting point, and this will be the atomic number. Already I have taken here. So in this graph you will get like this and this, then will be this and this. Why? Question is here, why graph is like this? Because up to fourth elements at melting point and boiling point gradually increases, because unpaired electrons gradually increases up to middle elements, up to fourth elements, because first electrons enter in d1, then d2, then d3, then 4, like this. And so number of electrons gradually increases and unpaired electrons increases. As a result, metallic bond also increases. That is why they have the high melting and boiling point. And then further, unpaired electrons in d orbital decreases, because electrons enter in d further, and it will get here the d6, d7, d8, d9, like this. Once again they start to pair, and their unpaired electrons gradually decreases. As a result, metallic bond also decreases and melting and boiling point decreases. But now question is here, why the middle elements having the abnormal lower melting point? Because in middle elements having most stable half field configuration, D5 and 4s2, this is called the most stable half field configuration. As a result, delocalization of electrons does not take place in manganese, and this one does not take place. As a result, the metallic bond become weak and the melting point also decreases. So this is the properties of melting and boiling point of transition metals. Okay dear, now you pause the video and write down all these points.